right? Okay. So we at JFrog have a long love story with Groovy. Along other things, we host Groovy on Bintray. When you download Groovy, you download it from a JFrog platform. Groovy is developed using Artifactory, another JFrog product. That's how they use us, and this is how we use them. Bintray UI, actually not only UI, most of Bintray is written in Groovy and Grails. Artifactory plugins, the user plugins, are written in Groovy. And recently we also started hosting the Grails plugin portal on Bintray, and Grails plugin portal been there for a while. So that's why I'm talking with you about Groovy. I love the language. I think that it is the best language on the JVM, you know, if you look for alternative for Java. And what you are going to see today are the Groovy Puzzlers. That's the second season. Anyone saw the first season? Okay, couple of, two hands, couple of things, like 2 hands. All right, so it's not a prerequisite. You will be just fine without seeing the first one. We do some nice references that you won't get, but that's okay. And the puzzlers format wasn't invented by us. Who knows those guys? I'm the only old one in the... Okay, so this is Josh Block and Neil Gaffner performing the Java Puzzlers. Who know about the book Java Puzzlers? Okay, right, yes, great book. The book Java Puzzlers is based on the talk, the Java Puzzlers, which is constantly run, I don't know if until today, but until a couple of years ago, started from 2001, eventually by those two guys, and later when they left Sun and Oracle, etc., by other people as well. And they call themselves the Click and Hack, the Typing Brothers, and there is a reference to an American radio show that probably none of you know, except of Tim, I guess, right? Those are the Click and Clack, the Tappet Brothers, from the car show, which is a radio show running from 1977 until today. All right, so the rules. The rules for the Groovy Puzzlers are from the rules of the Java Puzzlers, and they are very simple. 2 guys on stage, so I need the other guy, and I have him. Please welcome Tim.
That's my favorite picture, Baruch, thank you.
Yes, I knew it.
That hurt.
So, yeah, this is Tim, and he knows how to say his last name in Swedish.
Would you like me to do it?
Yes.
Berglund?
How was it?
No, I'm not doing it again.
All right.
Was that okay? Berglund. I say Berglund.
All right. So,
Apologies.
2 guys on stage, funny and puzzling questions. They for sure will be both funny and puzzling. That's okay. Now, it's all about interaction with you guys. The idea is that you vote for the right answers. You think and vote, and now, chances are, who uses Groovy here? All right, okay, it's about half. So whether you use Groovy or not, chances are you will be wrong. And, but that's okay. You still should vote, but there is a great reason. You can guess, it's only 4 answers, so you have 25% of guessing right. And if you guess right, like twice in a row, your neighbor will think that you are a very smart guy, right? So you should vote anyhow, whether you know the answer or not.
And there were a lot of people who are either not raising their hands or not using Groovy. And even though you see the things you're about to see, you should still use Groovy. It's a good language.
That's a very good point. So we are doing this show a lot. We did the first season for, I think, 10 different conferences, and for the second season is as well. And what we see is that there is no enough disclaimers that we can wrap this talk around, right? What you are going to see is valid Groovy, but no one writes Groovy like that. So if you think, what is this horrible thing, I will never use it again, don't. This is not the canonical Groovy that you usually encounter. We do it for fun. This is not what you are going to see in real life.
My team has a custom Gradle plugin written in Groovy. You'd get fired if you did any of this. That's just, yeah.
Yeah,
But
absolutely.
you're going to learn.
Yeah, and laugh. All right. If you do know the answer, we have most awesome Groovy t-shirts that we're going to throw at you. Probably Tim will going to throw them at you because he's probably better than that. We didn't try, but my bet is on Tim. If you were right, that's a t-shirt. When I have those stress-relieving frogs, when you see the puzzlers and you're like, then you do that, and that's okay. So that will, the frogs will throw as well. We have a Twitter handle, so if your emotions are going through the roof and you have to tweet something, use this hashtag. And there is, the most important rule is you shouldn't cheat, right? So whoever have this laptop open, no IntelliJ, no Google, no YouTube with recording
No Groovy shell.
No YouTube with recording of this talk from any previous conferences.
That's right.
Don't do that.
And Baruch, there's a difference between frog and t-shirt based on your answer, right?
Yes.
Okay.
Right.
Should I explain?
Go ahead.
So if you get the answer right and you can tell us why, you get a t-shirt. If you get the answer right and you can't really tell us why, then you get a frog. Not that the frogs are bad, but t-shirts are better.
Okay, anyone knows how Sadogursky looks like? One of the core committers of Groovy. Okay, and the same two hands. So this slide is for you. This is how he looks like. Right, okay. So we tested all the puzzlers for the latest version of Groovy, and they all work or fail as expected with the latest version of Groovy, so it should be good. Are you ready? Yay! All right, let's go. So, Tim, I think you should start.
Okay, let's see if this works. It works. Okay, we're going to start with the alphabet. This is so easy. Now that dot dot, you guys know what that is? That's the range operator that creates a range between the first thing and the second thing. So, what do you expect this code to do? It's going to iterate over the range, maybe, and maybe do this. A, B, C, D, E, F, G, H, I, J, Z, or, as they say outside of America, Z. B, no such method error. C, Z. Or D, it won't run. So.
Well, what I see here is pretty obvious. I have this range, and I print each element of this range, so it will be A.
So you say A?
Yes.
Okay.
My answer is A.
And now we have to vote. That's a strong answer.
I know my Groovy.
You do. I mean, I don't trust him personally, but can we vote? And I want to see hands. This is only fun if you vote. You got to take a risk. Maybe you'll be wrong.
You'll be wrong.
But who's with this guy? Give me a hand for A.
A.
Hands up for A.
All right.
All right.
Yeah, there is some trust here.
And I do like the world you guys live in.
Yeah.
I like
people trust me. That's good.
It's a good world.
Yeah,
Yes.
yeah.
Who says B? Yeah, you've been hurt before, haven't you? Yeah. Okay. No trust at all.
How about C? Right. Okay,
All right.
That's a good distribution.
That is a good distribution. And D won't run.
Yeah. Well, that's true. It's Groovy. It always runs. It might end up in a completely different way that you expected, but it will run.
Now, ready for the answer?
Go ahead.
It is C, Z. Now, how do we pick a winner here, Baruch?
No. Who knows why? Go ahead.
I think, at least, it's because you're running it each on the Z, and it doesn't form the range A to Z, it forms something else. But the dot binds to the Z character.
How can we fix it, to make it a little bit hard for the t-shirt? It's already a frog. Perfect. That's a t-shirt.
Safe answer. Orange or black? Orange, which
Right.
I'm told
is... We have plenty of sizes and colors, so you can trade.
The new black.
Yeah. You can trade in the end if you didn't like the color or the...
Okay, and that is, by the way, correct.
right? And you do fix it with the parentheses. Now, who knows who this guy is? Thank you very much.
He was not embarrassed about parentheses, was he?
Yes, yes, right. So you can fix anything with parentheses. There is a joke about Chinese stole the source code of American nuclear reactor.
That doesn't sound very funny.
Yeah, the problem is they only managed to steal half of it, and it was written in Lisp, so all they had are closing parentheses.
Those are some deeply nested functions.
Yes.
Okay. And this puzzler is credited to Mr. Ken Cousin.
Right?
Yes.
Yes.
Mutual friend of ours and stalwart of the groovy world and great speaker. If you ever see him at a conference, you should. He's a good guy.
Yep.
Yeah.
All right.
All right. You get this next one, right?
Yeah, okay, my turn then. Well, yeah, it will be a puzzler about.
I'll be back.
Right. So, again, pretty simple code. We start easy on you. So we have this string back, and then I create a list of strings that somehow contain this string as well.
All right.
So first time I use this dollar operator, the other time I use the dollar operator and the brackets, and then this arrow, and here it's only dollar with brackets, with the curly brackets, and then I just do string concatenation.
Gross string concatenation,
Right.
the last one. That's I don't know what kind of a person you are to even do that, but
Yeah, okay, that's the big thing.
that's just
And then I print this list and change this variable to be Bach and print this list again. And my question to you will be, how many Bachs will be printed during both of the print iterations? No Bachs at all, 1 Bach, 2 Bachs, or 3 Bachs.
I don't even want to give an answer. Do
You have
want
to.
me- Do I have
Those
to?
are the
Oh,
rules.
man, okay. And
People are looking for your wisdom to vote against you, usually.
my leadership.
Yes.
I'm going to go with no box.
No Bachs. That makes sense, because
Yeah.
it doesn't matter what you change there. Those are strings, immutable strings. It's all there,
Yeah.
right?
Yeah.
So who thinks like Tim, no Bachs at all?
Okay. Oh wow,
Wow, that's a vote of trust.
You're not,
This is how we call it.
you're not leading if nobody's following, as they say. So
Yeah, no, but you had a handful of hands. Okay, 1 Bach. Okay, plenty of hands for 1 Bach.
confidence.
Yes, 2 Bachs. It's about the same, nice. 3 Bachs.
Yeah, I don't know what you guys are thinking.
Yeah, no, that was desperate people.
Okay. But you know what? You guys are voting, and that's good.
Keep doing that.
Yes. All right.
The most bizarre answers will eventually be the correct ones. I promise you.
They don't get better. Okay.
So the answer is 1 Bach.
1 Bach.
Who knows why? Yes. It's a reference. What do you mean? All right. I think it's a frog for a carriage.
It's
right?
a frog. Look out, everybody.
Good job.
Almost. A little short.
Yes, please. That's a t-shirt.
That's a t-shirt.
straight
Orange or black,
t-shirt.
sir. Okay.
Good job. And that is actually perfect explanation. Only the closures are evaluated in runtime. All the others uses are inlined. So the real question is how many closures we have here. This is in no way a closure, and this is a no way closure. So the actual question here, how many closure, is this a closure? Absolutely, it has everything the closure needs. What about that? The answer is
G-string.
Not for strings.
Right.
It would be a closure in other contexts, but not in strings.
Not in a string. That is because the arrow is there. And I want to emphasize that's completely terrible. But it's a closure.
It's a closure, it evaluates in runtime, and it's actually a pattern, for example, in Gradle plugins, when you want to defer decisions to runtime, you wrap them in closure. And Gradle API allows in almost every place when you can use an object, use a closure as well to defer the evaluation to runtime.
Yes.
That's exactly what
that's
happens
the
here.
whole configuration thing in Gradle.
Okay, and this was donated to us by Cedric. Now you can compare to the
Shampoo.
picture you saw in the first slides. It was actually complete look-alike. All right, I'm ready for the next one.
Ready for the next one?
Yeah.
All right. Wait, I'm answering this. You're explaining this, I'm explaining this.
You were supposed to explain it, but I can take
I
it.
just lost track of where we are. All right.
It's your turn, basically.
Okay, good. I'll go. Okay, you have a story about this, don't
Yes.
you? Yeah, Baruch, tell us this. This is, I'll just kick you off, an actual image from his laptop during a presentation.
Right.
Ladies and gentlemen, the blue screen of death.
Yes. This is Spring 1.2JX a couple of years ago. I was talking about Groovy. Obviously, the screen was recorded and this happened. But I tried to understand why, and I think that I got to a conclusion that it's because I typed 666 when doing the demo.
Yeah, and now you know not to do that. So, because you can't do that, you've had to do a little bit of research and development and come up with alternative ways of expressing the number of the beast
Right.
without actually typing.
Do you have any ideas for me? How can I do that?
I do. In fact, Baruch, I have 4 of them.
All right.
All right. Here's number 1, or A, as it is affectionately known. Beast equals 6 times pi.
That's an interesting definition of 666.
I
All
think
right.
if I was going to put a comment on that, it would just be #seems legit.
Yes.
And I'm not above it. Okay, this one is 6, the string, times 3, the string.
Okay.
C is 667 minus 1. Number of the beast, little, arithmetic. 111 times 6, 667 minus 1. It's all the same. And this is 6 plus 6 plus 0 plus 6.
That's the safe 0 here.
That's the safe 0. I'm carefully omitting the types. Now,
Yes. So I would say that everything except A seem legit. So I can pick any of them, and I think I will go with C.
C. Okay.
Yeah, that looks like, why not?
Sure.
That should work.
Yeah, it would work in JavaScript.
Everything would work in JavaScript.
But what even is a number? All right. Some votes. Keep raising your hands, people. Who's with A?
Okay.
All right. All
Hands
right.
for
Some
A.
enthusiastic
Good.
response for A. B. Who's got B? Okay. All right. A couple of lone rebels cry out in the wilderness. C. Who's with C?
C, that's mine.
Ooh, Baruch.
Yeah, my influence dropped dramatically.
Get wrecked. Okay. D. D. You guys love D.
Oh,
All right.
nice.
All right. Well,
Okay.
are you ready? All right. Those courageous few who said A were correct. All right.
Okay, who knows where is my surprised face? Yes. Who knows why? Yes. The gentleman in a blue t-shirt. Well,
Is that a frog or a t-shirt?
yeah, that feels like a frog.
Feels like a frog?
Yeah.
All right.
That's much better.
And multiplying a string times an integer does what? Yes.
Yes.
Apparently so. You're
Yeah.
still in t-shirt territory, orange or black.
That's good.
What's that? Black, you got it.
You see how you do it? Now, you omit this, apparently, and you look like man who knows Groovy, right? That's rookie mistakes.
That's right. That's right. Speak confidently. Drop it. So yeah, that's exactly what happens. This, remember, that is evaluated to that, and the 3 simply rounds. I guess we need to dig a little bit deeper here. So let's look in Groovy Core, in the Java docs for multiply. All right. So when you multiply a string by a number, That means repeat the string that many times, but that only makes sense if the number is an integer, and so it is in fact coerced to be an integer. So you can multiply a string by a real number, and you'll just coerce it to an int and repeat the number that many times. That's what it means to multiply a string by a number in Groovy. So this is really this. Yeah.
And that's how it works.
Yeah.
How about the rest?
Yeah, so
We
this
had
guy.
we had a lot of valuable options.
Yeah. So what's going on? We wanna poll people?
Yes,
Okay.
that,
all right.
that will be at least frogs easily.
Yes. Okay. So for the frog, what does this do? Excellent.
Next, let's explain why. Multiply. We saw multiply for an integer,
There
and
is-
it worked.
Yes.
But
there is no overload for string and string.
Right.
Yeah.
Yeah. Next one.
Okay. Next one. 667 minus 1. What's it going to do?
We expected better from you.
No.
We're almost done with all the possible options. That's a nice option, but no. Yeah, that was the 66 option. Okay, I'll keep the frog.
You keep the frog. Subtracting something from a string tries to remove that substring from the string.
For a number as well. It will coerce it to a string, and then we'll try to remove it.
And there is no 1 in there, so that substring doesn't exist, so that returns 667, not the number of the beast.
And the last one.
The last one, what's it going to do?
That's the easiest one of all.
I heard somebody say it. It was back there. Yep, she
Yeah,
gets frog.
too late?
She said it first. She gets
All
frog.
right,
She
go
gets
ahead.
frog.
I didn't see that.
Oh,
I think she
terrible
already got the frog.
Well-
But yeah, that's fine.
There you go.
2 frogs are twice better than 1.
Yes, because the 0 will get coerced to a string, and then same thing, when you concatenate the other 6, it'll say, well, make this a string. How could I fix that? How could I make that the number of the beast? Always the correct answer, parentheses.
You see, Groovy is easy.
So, yeah, because then the 6 and the 0 are evaluated first, and everything is great. All right, and T-shirt here went to
Larry.
Laurie.
Yeah,
Oh, Gradleware,
Larry.
our friend.
Yes. All right. Okay, now I love the next one.
All right.
So, who knows the movie? Who is old enough? Okay, good.
I'm most definitely old.
Well, yeah, that's the Epic Highlander.
How many can there be?
We will talk about it now. So I will tell you how the movie goes in code. Well, there is a guy called MyCloud. Whoa, that's almost a blue screen of death, but not quite.
What? Okay.
No, it wasn't.
Oh,
It
that's
was, yeah, JavaScript. That was JavaScript.
That was Java. That was somebody had a web browser running during presentation.
Right.
Okay.
Yes, rookie mistake. Talking about rookie mistakes. Right. So yeah, so there is this guy McCloud runs around and shouting, "There can be only one." Always shouting. That's why it's all in caps. So what we have here is a class. There can be only one. There is nothing into it, and then there is a class McCloud get. There can be only one that returns an instance of there can be only one, which makes sense, right? And that's the code, and now here is my kind of test. I print McCloud, there can be only one. Right?
Sounds fine.
All right.
I like this. Yeah.
Options.
What are my options?
It won't start. No such property, there can be only one for class McCloud. There can be only one with some hash.
Blah, blah, blah.
And something else went wrong.
Want me to answer?
I want an answer from you.
This code looks fine to me.
That might happen even in a puzzler.
This could be the anti-puzzler. I'm going to go with C.
All right. Sounds legit. Let's vote. Who thinks it won't start? Yeah, one hand, it's groovy, it will start. All right.
Yeah, you're
Good,
all wrong.
safe. All right. No such property. Who thinks that the property getter won't run for some strange reason? All right.
All caps and something, I don't know. Yeah.
How about it actually works? Good job
No,
of
they're not.
leading team.
They're not feeling it.
Guys, this is the Groovy Puzzlers, why it will work. Or something else went wrong. I would say that's the most safe bet here, but...
Seems like it.
All right. So the correct answer, of course, is something else went wrong. Okay, now the next question will be, what went wrong? And here are the options, team. Multiple compilation errors exception. Stack overflow error. Null pointer exception. Something else went wrong. See pattern then, right?
D.
You know that we are limited in time that we are doing this presentation. We cannot go all day with that. All right. Who thinks multiple compilation errors exception? Right, couple of hands, just because now everything can happen, right? How about Stack Overflow? Stack Overflow, it's a good, solid choice. I didn't ask you, what do you say?
I said D.
D, all right.
Oh, yeah.
You said D,
I
right.
said D, yeah.
How about null pointer exception? I don't know about you, and I completely cannot understand why there is only one hand. Null pointer exception is always a good option. Doesn't matter what the code said, it's null pointer exception.
But the correct answer.
Stack Overflow. Anyone has any remote clue how the heck there is a Stack Overflow in this code? Well, that's how you get Stack Overflow. That's not even a frog.
That's a good guess. Do you have an account of what? You want to show the code? Can we show the code again?
Yes. Let's see the code again. That's good. Here we go.
There we are. So where's the recursion?
Yes.
It's the class equals, there can be only one. It's calling the getter over and over again.
Wow, that's a classic T-shirt.
Solid.
Solid, absolutely
You already have a
solid
T-shirt. You
T-shirt.
already- Okay, well, you get a frog. Oh, well,
We need to get him out of the room.
yeah. Okay, good job. Good job.
Yes,
You're absolutely
that's
correct.
absolutely
That
correct.
calls the getter, which calls the getter.
Right, so what we have here is this. Yep. That's how properties work. Right? Okay, now what do you say, how about we are going to fix it?
Yeah.
Let's fix it.
You tell me how to fix
Yeah.
it. Okay.
So one option will be not relying to the fact that Groovy assumes that whatever cannot be anything else should be a class, right? So here, what we do is there is no dot class in the end because it's Groovy. In Groovy, you don't need to say dot class for class because it cannot be anything else.
If it's the name of a class, it's implicitly the class.
Right.
Which is good, right?
But maybe here Groovy needs a little help.
Yeah.
So let's add dot class here. So what we are going to have is something like that.
It was a good try.
Okay, who thinks that will actually fix it? Do you think it will fix it?
What does Christopher Lambert think?
Who thinks it won't fix it? Guys, you should vote. Of course it won't fix it.
Christopher Lambert says, ha ha ha.
Why it won't fix it? Because of that. It will do the property first, and then it might append the class.it, but this will never happen because we have Stack Overflow.
Right.
I have another fix for you.
Okay, good.
Now let's cast it to class.
Okay, cast
Yeah.
cast what to class?
There can be only
yes,
one.
Yes, okay, good.
That's the strongest as it can get.
Right.
That's good, that's solid.
Always cast.
Who thinks it will fix it? Who thinks it won't fix it? Of course it won't fix it. Why? It will still do the property first.
Christopher Lambert laughs at you again. It's terrible.
We will do the property first, get into recursion, and we'll never get to this cast at all.
Right. There is nothing.
Well, the only way that you can fix it is stop shouting and writing stuff in caps that shouldn't be in caps, right? If you write it correctly with the normal camel notation, it will be fine because your class will start capitalized and your property won't start with capitalized. And then this is how it will be distinguished.
Follow the idiom and nobody gets hurt.
Exactly. I'm ready for you.
Okay.
Oh, first of all, we need to say thank you to this guy. He got his T-shirt for this most awesome puzzler.
What's his name?
Kirill.
Okay.
Yeah.
All right. Thank you. Pirates.
That's a reference for the first season, whoever saw it, but you will be fine without it.
Okay.
Let's talk pirates.
Let's pluck pirates, and what do pirates do? Well, they capture ships, they pillage, they take things, they accumulate treasure, they bury the treasure, and how do you keep track of where the treasure is? A map. So, we're going to play with maps. This is our pirate-themed code, and let's just take a look at this. We've got that nice AST transformation there, inherit constructors, and AST transformations in Groovy will work kind of with the compiler to do things that you can't do in a conventional transformation. So what this is going to do is go to the hashmap class, get its constructors, and like the thing says, now our tray map, or whatever that is, we'll call it tray map, that has the constructors of hashmap. So that's nice. Otherwise, we don't really add any new behavior. Fine. Maybe we have a reason for this. And we create two of these, and we statically initialize them. You see the two static initializers, right? Good. And we print two things. Number one, the class of A, and then whether A is equal to B. All right? So we should see a class and a Boolean. There are four combinations of what we can do. A, it prints class hashmap and true. B, it's tray map, or whatever that is, and false. Tray map and true. Hashmap and false, those are our four options, Baruch.
So it will run. We don't have it won't run option.
It's going to run. We're telling you, it's groovy, it's going to run.
All right.
Yeah.
So I'll tell you what. I'll tell you my thinking. By default, when you create a map on the fly without using new and the class name, it will create a hash map in Groovy. And then it will, and then by polymorphism, the type of the variable will be trailer map, but the object itself will be of the hash map.
The runtime type is a hash map because we did a static. Okay.
Yes, because we initialized it in this way, and this is what it does.
Okay, that's legit.
And now, I would say that usual initializer, when it is key and then semicolon value, is not used here. So maybe I would say that the value is null. So here we have two maps. In one, the key is 5 and the value is null, and the other one, the key is 6 and the value is null.
Okay.
Which are not equals, of course, because the bindings, the pairs are different. So I'm going with hashmap false, which is option D.
Hashmap false. And that was good, groovy reasoning there.
Right.
I'm sure he's won you over. That was pretty clean. Who wants A? Hashmap and true. Okay. Who wants B, tray map and false? Who wants C, tray map and true? Well, look at you. And D, like my esteemed colleague, Mr. Sadogursky. Okay.
Thank you, guys.
Hash
Appreciate it. Yes.
And false. Survey says.
Good job, guys.
You were doing well.
Yeah, you got the idea. The most bizarre answer should be right. Right?
So, who is willing to give us an explanation?
You didn't get a T-shirt today, Kiro. So, yeah, you have an option here. Yeah, go ahead.
So, you're inheriting the constructors of hashmap. Hashmap has a constructor which takes one integer argument for the capacity. And what you're using here in the syntax of schema A equals brackets 5 is the generalized constructor. So we'll pick up that constructor with the capacity and build an empty tree map, empty map.
Yes.
And the same happens for 6, which has different capacity but equals the first one because it has the same number of entries.
Ladies and gentlemen, this is
home run, as we say, as my people say.
Well, I think I know why. Mr. King is one of the co-authors of the best groovy book out there.
Gina.
Called Groovy in Action, 2nd edition. Thank you.
Orange or black?
I take the orange one. It's so much like in
Yes, yes, yes. All right, let's just, large, you got it. Let's see if I can get this safely
right.
to you. They open. All right, yeah, let's walk through that. So the answer to this, if I may, Baruch, is to
Read the documentation.
read the documentation. That's a different manual he's holding there. But, and basically the documentation says exactly what Dirk said, that and you have to understand initializing the object to a list. What that's doing is saying this list is a list of values, and now go look for a constructor that takes these same types and call that constructor. Well, it was a list of one value, which was an integer, which is initial capacity. So
We inherited this constructor
we
from
inherited it
HashMap.
from HashMap. So again, I think you should probably get fired for writing that code, or at least disciplined.
Yes.
Yeah, probably a formal review and reprimand. But that's what that code does. And there are times, there are kind of metaprogramming times where that's not so wicked. But here, that was just a terrible thing. So yeah, one of them had initial capacity of 5, one had initial capacity of 6, equals does not evaluate initial capacity. Who cares about that? The maps had the same stuff in them, which is to say, nothing. So
Well,
there you go.
so
Yeah, and yeah, here in slides that 5, it inherited the constructor's initial capacity. It is just as we said, and
Eagles does not care about. initial
does
capacity.
not, just the mappings, which you'd think.
All right.
T-shirt goes to Sergey.
Yeah, another guy from somewhere in the north. Well, we are in the north, so in the east, I would say, right?
Yeah, we're at like,
Yeah,
I think 58, 59 degrees north. This is,
yeah,
it's north.
that's pretty north. So to the east.
I've been norther.
Yeah, northern. Yeah, that's right. Oh, this one I like.
All right, please.
So the next one is called collect all the elements, and we're going to collect some elements, guys. Okay, so here is the code, and for those of you who recognize the reference, right? Sheldon, Big Bang Theory, right? Okay. So what do we have here?
Oh, I totally did not get that.
Oh my God.
I don't
Tim.
watch, my mother-in-law loves that show. She says Sheldon reminds her
Right.
of me.
Absolutely.
I
That's like a show about you.
I watched it once and I'm like, I just don't think that they're really getting geek culture right. And then I said, wait a second. I'm sort of doing it right now. Anyway, go ahead.
It is good. So we have class kitty with variable for, and then we have list of kitties, one of them initial defer to soft, the other to warm, and the third to poor. Okay?
And that's a constructor syntax where you pass a map.
Yes.
And you will initialize the properties of the class with the map keys and values.
Absolutely.
Yeah, beautiful. That's why I love Groovy, you guys.
That's a beautiful way to make a list of objects that will take like a screen-long code in Java.
Yes.
Yes. And now we collect the value of the for property in 3 different ways. First, we'll use the collect method of Groovy object. We pass a closure that will be evaluated, and the return type will be the one what constructs the new list, and then we print the new list.
Iterating over the collection and making a new list out of the stuff we return in the closure.
Exactly.
Just
That's
getting
what
the-
collects does. Spread dot operator does exactly the same in a more concise way.
Dot spread.
And Groovy
Doesn't
is
really need the spread.
smart enough to say, you know what, here I don't have a for property on a list. So let's look at the objects inside the list. Maybe we will be lucky enough to find this property inside objects instead of just failing, which is awesome. So my question for you will be, what will be the
Okay.
output?
Okay.
How many of the printed lines will be the same? All will be different, 2 similar, 1 different, all will be the same, or it won't run. A hint for you, statistically, B will cover the most options.
Man, I'm just gonna take a guess. I'm gonna follow you. I'm gonna go with B.
All right.
I'm gonna go with B.
Okay, guys, what do you say? Will all of them be different? Who thinks A? Okay? Will you go to the safe option of B, covering the most possible options?
Right.
Good,
That's
smart
my
guys.
people, it's my people.
How about all will be the same, how it should work? A lot of hands here, or it won't run? Yeah, a couple of hands, although it's groovy. Okay, so the correct answer is they will be all the
It
same.
actually works. What kind of a puzzler is this?
Well, yeah, you might ask what kind of a puzzler is that, because that was too easy. But here comes the actual puzzler. A little twist to this code. I just want to initialize the list. I have the same class, I have the same list or whatever it will be now, without any initialization, and then I have the same print. And
The only difference is the list is not initialized. It's not a list.
it's not a list.
The value of kitties is,
Whatever it's
sure.
by default.
Okay.
And the question is the same. How many of the printed lines will actually be the same? Will they all be different? The safe statistical option, will they all be the same or it won't compile? What do you say? Tim? You won't escape from it. You need to vote.
Dang it. I'll go with all the same. I'm going to say it's going to be the same thing again. It's going to
Yeah,
be the right thing.
because two puzzlers in a row that are not the puzzlers
No,
makes
wait.
perfect sense.
No. Yeah, I'm sticking with that.
All right.
All right.
Who thinks they all will be different? Right, okay. Who thinks two will be similar, one will be different? That's a safe bet.
All right,
How about they still will be the same? I have no idea what I'm doing in this talk. Okay, couple of hands. How about, although it's groovy, it won't even compile? Okay.
That's a tough sell.
Good,
but
good
maybe,
hands.
maybe we'll see. We'll see.
Yeah, all right,
Yeah.
okay. Are you ready?
Oh, boy.
They all will be different. Any idea why all of them will be different?
Walk us through it.
Yes. No, you won't get a frog by just raising your hand. No.
Come by the booth.
You need to say something. Any ideas? Yes.
Yes, it can deduct this list in at least one of the cases.
Okay, that's actually true. It will deduct that it's a list in one of the cases. Yeah, you know what? That's a frog.
You think?
Yeah, there is a list somewhere in the code that
He doesn't
we're
know
going
which
to say.
one, but
Yeah, no, that's a frog.
which one do you think is a list? Okay. All right.
Yeah, okay, yes, so that's a frog. Yeah.
Yeah, that happens to be
that was a hard one, guys, so that's fine. Okay, let's look at the simplest one. Simplest one is that. What it's going to do? Guys, come on.
And
Thank you very much. It is null pointer exception.
Yeah.
Plain and simple. There is no way around it.
Right. That thing is null, and we are.
That's the
doing
last option. Let's now look at the first one, the collect one. Well, the reason this one won't be null pointer exception is actually interesting. The collect method actually does not exist in Java object, right? We all know that. That's what we call an extension method in Groovy. Extension methods are static methods in completely different class, which means that it won't fail all null pointer exception.
So the compiler is seeing this method call and says, I need to go to this static class I've got lying around and call this utility method to do this thing.
That's why this is not null pointer
That's what the
exception.
JVM thinks is happening. It's not looking for a method on null.
Object,
Yeah.
or on object, right?
And
so that's why it's null pointer exception. Now, how it works, before we can collect anything, we need to convert whatever this is to a list. So we have this another utility method, which is
Inside
as
collect.
collection.
This is inside collect.
Yes.
Okay.
It will call as collection again on the object and pass the value, and here we have a nice null checking that will return an empty list instead of failing. So what we're going to see in this option is printing of an empty list.
So that is as if you are calling collect on an empty list.
Yes.
The thing in the closure is never evaluated, So you get an empty list because there's nothing to collect over. Okay, which is nice behavior, right? Null, collect, it doesn't explode.
Yes.
Yeah.
The third option is the spread dot operator, which actually explains exactly as it works in the documentation, right? So the spread operator is null safe. If the key is null, we will get null back instead of null pointer exception.
Which is nice because a null safe spread would be question mark, asterisk, dot. It would look like profanity or Perl. So I think this is good that Groovy works this way.
Yes. So this is why, and of course, all of it inside the documentation. And what you are going to get is an empty list, null, and eventually a null pointer exception. Yeah. All right. So as Tolstoy said in Anna Karenina, all happy families are alike. Each unhappy family is unhappy in its own way. When we initialized our collection, it was just fine. When we did it, they failed in many different ways, right? Okay, we have time for one more.
You think we do?
Okay, so I'll tell you what.
All right.
We have, Dan absolutely got a t-shirt for that. There is nothing in this room after this talk, and we have a couple of more puzzlers. You want to stay? Let's roll.
All right.
Go ahead.
Let's roll with these guys.
All right, that's right, guys.
I have,
roll.
for the flight home, I have Expendables 3 on my laptop. I just want you to know that.
All right.
Or my iPad. Pretty excited. All right. Oh, this is so awful. I wish we had stopped. I can't stand doing this to them. Okay, so what we're going to do is we're going to make a list. It's an array list of strings. It's a little more explicit than you need to be in Groovy, but fine. It's the Expendables, Arnold, Chuck, and Sly Stallone. And now we're going to set the expendable variable to one of them, right? Then we're going to run that code for hero in Expendables. Hero equals expendable. Expendables remove hero. At that point, that doesn't even look like Groovy. In fact, that's just Java there, isn't it? Yeah, okay, so that's great. And then we'll print the expendables.
Awesome. What's the question?
The question is, what is the question?
Just give it.
Next.
Yes.
There we are. Which one of these will not cause a concurrent modification exception? So hopefully when you saw the iteration over the collection there and modifying the collection, you got a little, anxious.
You all know that you shouldn't do that, right?
Yeah, it's just death.
And you all know that Groovy or Java will protect you from doing it by throwing a concurrent modification exception.
Usually.
We're all on the same page here.
Yes.
Good.
So, good. Now, here's the question. The question is we're trying to set expendable equal to something so as to avoid a CME. Your possible answers. A, can't avoid a CME. B, Arnold. C, Chuck Norris. D, Sylvester Stallone or Sly. Baruch.
That's obvious. The only one who can avoid anything, any exception, is of course Chuck Norris.
Chuck Norris, yeah.
Yes, I would foresee.
He only throws exceptions.
Yes.
He never has to catch them.
Yes.
So there you go. Give me an A. Who wants A? Can't avoid it. Gonna happen. Your host. Okay. Who says B?
Oh, no, I would foresee. Okay.
C?
Yes.
Yeah, you guys
Chuck
are with
Norris.
Chuck.
Yeah.
D? Yeah, last one on the list. That makes a lot of sense.
Yeah,
Well,
that's
guys.
All right.
He wasn't lying, okay?
Who knows why? Any idea at all? This is the most horrible puzzler of them all. Yes. Well, there is some truth in that list will be ended after we remove Chuck Norris.
Yes. Is that a frog? I think that's a shirt.
It's a shirt?
You think a frog?
Well, I think that's the best we can get, right, for this puzzler.
Yeah.
It is complicated, so maybe it's a shirt.
Okay, shirt.
Yeah.
Shirts won't throw that far, so come on, get when we're done. Let's just finish this up.
No, that's the fun. Black or orange? All right, I will throw it. I
Now,
don't care.
the docs for concurrent modification exception warn you
You did better.
in the fine print, right down here, presence of unsynchronized concurrent modification. Fast fill operations throw concurrent modification exceptions on a best effort basis. Therefore, who knows what's going to happen? Maybe you'll get one, maybe you won't. Don't do this. So let's actually decompile or start compiling this. What it's going to translate into is creating an iterator on the expendables, and then while has next, it's going to be a while do loop. While has next, iterator next, and then do the test, and then do the remove. That's what the Java iterator syntax converts into. So we need to keep talking here, don't we? Iterator has next. If we remove the remove,
We would try to see how that works without.
yeah, let's just the non-pathological condition. So let's look at the implementation of next. It checks for a concurrent modification exception, but only when we're inside the next iteration.
We remove here and we check on the next while.
Yes. Then it sets us up. It moves the cursor forward to the next element in the collection, setting us up for the next iteration. But that's setting us up for the next call to has next, which will exit when we're equal to the size, when we're just one past the end of the thing, right? Good enough.
So far, so good.
So if we say Sly, who was
Now
last in the
let's-
list,
yes,
right? Yeah.
yes.
After Sly, then the cursor is going to be 3, because Sly was 2. We'll increment it. It's 3. We'll get to 3, and we, at the next has next, and we're done. So everything's good. We finish the list. Now let's uncomment that line and set it equal to Chuck. So after Chuck, the cursor is 2. Then, this is after we call next, then we remove the element, which is going to make the size what?
2.
I think 2. You can check our math. Then we'll come back around to the top of the loop, call has next, and it says the size is 2, and it says, oh good, we're done. Everything's fine. And so it won't be able to check for a concurrent modification exception because it will exit from the loop. Yes, Dirk? Yes.
Yes.
So this
Yes,
this
you
is-
are horrified for a reason, and it's not even a groovy puzzler.
Yeah. This is really a Java puzzler. All right. So with Sly, so let's
Why it didn't work? Why with Sly it won't work?
yeah. So after Sly, the cursor is 3, and then we remove the element, making the size 2. So now the size is 2, they're not equal, and it will go in for another loop, and it will catch the concurrent modification exception.
Now, I don't know what's more horrible, the previous one or this one, because in this case, it will only get to check the concurrent modification because it will forcibly go to another iteration after we already left the loop entirely. The only reason why we won't fail on array out of bounds exception is because we fail on concurrent modification exception earlier.
But it's a good thing we checked because we were just about to trip on array index out of bounds.
This is horrible in any possible way, and it's not even a groovy puzzler.
Right. Which is why you don't do that with collections.
Yes. Okay,
All
so I think we have that. Yeah, and Evgeny did all this work of trying to understand what the hell happened there. I think we are like in -4 minutes.
Yeah, we should probably.
So we should probably go to some conclusions, and that will be short, I promise. So those are the conclusions. With great power comes great responsibility. Groovy is far more powerful language than Java, much more expressive. You can do functional programming with Groovy. You can do object-oriented. The syntax is very powerful, but you have much more ways to shoot yourself in the foot.
Yeah.
Right? So you should do that.
Please, unlike what we've done here.
The puzzlers are not set to be an example. Don't do what we just did. Sometimes the tricks are so good, you're tempted to use them.
Right.
And that's fine as long as you document it for the future self, who will probably be the reader of your code.
Yes, you're really writing the code for another human to read. Writing it for the compiler to understand, that's easy. It's hard to write it so a person can read it.
So yes, comments help. We didn't present any bugs during this puzzler, but sometimes as a bug. Much rarely that you anticipate. I have a friend of mine which for every time something didn't work just start to shout it's a bug in the compiler. Well, it's not, but in very rare cases it is. We didn't see any today. Static code analysis helps. In fact, if I would show you this code, whatever we just did, in IDE, in IntelliJ IDEA, for example, most of the puzzlers weren't puzzlers at all. IntelliJ would highlight you all the correct stuff and would warn you for every mistake that we made here, so you won't do that.
Wouldn't be any fun.
Read the manual. Groovy have a great new site with new documentation. It's awesome. And of course, we have this canonical book of Groovy in action. Read it. It will save you a lot of pain.
Quotations from Chairman Laforge.
Yeah, right. And of course, parentheses. Always, always, always use parentheses. So we hope that this will go to a third season. We have t-shirts already, not like last year. Go figure what we will do next year. No one knows. So if you encounter something in your sparse Groovy development, please do send those to us, puzzlers@jfrog.com or at Groovy Puzzlers on Twitter. That will be awesome. And we send t-shirts. With those t-shirts, but we also send t-shirts. Thank you very much. If you liked what you say, praise us. Fill the feedback form that Matthias will give you, and praise us on Twitter with the hashtag @GroovyPuzzlers. That's the Twitter user. This is Tim. This is me. And if you have any negative feedback, it is more than welcomed as well.
Thank you very much.